Hello guys, sorry I'm not in class today. Unfortunately, I'll be at my wife's aunt's funeral today. So sorry again that I'm not able to make it. I should be in class on Thursday though. And also regarding your grades will be updated this week for sure for his first semester. The reason you have not received an email from me yet is because I have had multiple students not make up the tests or quizzes or any other work that they might have had to do. So once I get all papers in, I should be able to update the grades. I'm hoping by Thursday I can have your final grade sent to you via email. With that said, you need your notes out for this, and you'll need a graphing calculator out for this as well, or Desmos, either one. But I'm going to go in and get going. Here's the warm-up that we have today, and this is not in your student journal, so please don't worry about touching those. Just go ahead and complete the warm-up here within your notes. Identify the degree of the polynomial. This is notation, vocabulary from way back in Algebra 1. The degree is the highest power that you can find. And what I can see here is that in number 1, the highest degree is 4. So that's the degree. In number 2, I see a degree of 3, 2, and nothing, so my highest degree is the 3 right there. That's your warm-up, and we're going to need a little bit of that for your for the lesson today, so let's go ahead and go into the lesson. And again, this still continues in your notes, so feel free continue to follow along. The question is, how can you determine whether a polynomial equation has imaginary solutions? And that we've kind of seen that before. For instance, like when we had a graph like this, where we saw that there was a bounce here. Let's say there was a bounce, and then there was the graph went through at a point. So it passes through. And we can see the end behavior here was an odd power, because that's what an odd power looks like with a positive lead coefficient. So odd power with positive lead coefficient. The question is, how do you know if a polynomial equation has imaginary solutions? So we're going to look at that and see, because this graph has real solutions. The real solutions are right here. These are called real solutions. And then there could also be imaginary solutions, which, as you might guess, we can't see. You can't see imaginary solutions on the graph. So how can you tell if there are imaginary solutions? And we're going to find a way to do that today. But for right now, let's go into the fundamental theorem of algebra. Believe it or not, this is actually really, really important, especially if one was to go on in higher mathematics. Again, this is called the fundamental theorem of algebra. It has a lot of words here that kind of make sense, but maybe not. So I'm just going to go down here and tell you what the fundamental theorem of algebra is, but I'm going to type it, because my handwriting, as Reed has pointed out multiple times, is horrible. No, I do not appreciate that Reed says that every time. So let him know that I am just offended when he says some stuff like that. Okay, the fundamental theorem of algebra basically states that the number of solutions that a polynomial has is equal to the degree of the polynomial. And you might be thinking, wait, I'm starting to write that down, Mr. Lakin, and that's basically what you told us before. Like, how do I know how many solutions something has? Well, I look at the exponent. That's the fundamental theorem of algebra. So I'm just deleting this random dot there. So that's basically what the fundamental theorem of algebra says. That's what that stuff says in more fancy math words. And we know this already, and that's good news for us. And in fact, you'll see that in the first couple examples that they'll be pretty straightforward, hopefully. Okie dokie. All right, so let's go to example 1 and 2. And by the way, if I went too fast, please pause the video and go back. How many solutions does the equation have here? So in order to answer this question, I need to be able to know the exponent. So I need to look at degree Okay, and keep in mind that solutions and zeros and x-intercepts are all the same thing, and that's going to all relate to the degree. How many solutions does it have? Well, the degree of the polynomial here is a 3. That is the biggest value. So this polynomial has 3 solutions, or 3 zeros, or 3 x-intercepts. And how many solutions, how many zeros does the function f of x have? So again, zeros and solutions are the same thing. We need to look at the degree. And the degree here is 2. Wait, no, it's not. It's not 2. It looks like 2. There's a 3 and there's a 4. Ah, it's 4 solutions. And be careful with that. We like to try to trick you guys with that stuff. But if you're paying attention, you're not going to fall for it. This polynomial has 4 solutions because that is the biggest exponent. So I'll just put a note here. If you're not sure if degree is still, this is called the biggest exponent that you can find. Okay, that's example 1 and 2 of 4. That's it, guys. Now the next ones, we're going to need a graphing calculator, so make sure you have one out. This one says to find all zeros of f of x, where f of x is equal to blah. Okay. We could try to factor this. Okay, we could try to factor this. But if we try to factor this, we're going to feel horrible. So graph it next. Graphing calculator should save us. So let's go to a graphing calculator and let's enter this equation in. I'm going to clear out anything that I have here. I'm going to go x to the 5th. I'm just going to type in what I have here, plus x cubed, and then minus 2x squared, and then minus 12x, and then minus 8, enter, and graph. Nope, I don't want to graph. In fact, I'm going to graph, but I'm also going to look at the table too, because here's why. When I look at the table, if there's any y value that has a 0, then those x values are solutions. Okay, so if I can find any x values that in the table that have solutions, I want to use those. So let's go ahead and go to the table here. The way I go to the table is second graph, because that's the table. I see some already. I see -1 and 2. I don't really see any others after that, but I definitely see -1 and 2. So let's use those. I see x equals -1 and x equals 2 from the table. So from table, oh, that looks horrible. I see x equals -1 and x equals 2. Now, I'm going to go and do some synthetic division on this. All right. So let's go and do synthetic division here. Oh, this is horrible. Looks like chicken scratch. I'm going to bring this down here so I can actually see what I'm supposed to do. So, haha. Okay. And again, x equals -1 and x equals 2. So let's see what we have here. Let's test -1 first. I'm going to have to go soon. My little kid is going to be left outside in the cold. That wouldn't be good, would it now? Okay, and now I have x to the 5th. I need x to the 4th. I need x cubed. I need x squared. I need x. I need a number. Okay, my coefficient for x to the 5th is 1. I have no x to the 4th. I have 1 x cubed. I have -2, -12, and -8. I can't tell you on your quiz how many of you left out placeholders. If you're not sure what a placeholder is, it's that thing. So please, please, please make sure you're putting your placeholders in. Let's do the synthetic division here. Please note that number is the 0. That is the solution. So I had students on the test wondering what number to put in the box. That number is the solution. Okay, now let's do the synthetic division. I'm putting down my 1. I get -1. I get a -1 when I add it. I'm just going to stop talking because I'm probably not being listened to anymore. 880. Perfect. I want a 0. Why do I want a 0? Because the table told me that I should get a 0. Let's put that in. What color was that? Purple? No, red. Okay. From table. They told me I was supposed to get a y value out of 0, or a remainder of 0, and I did. Okay, next. Now what I'm going to do, and I don't know if I've done this before, is I'm going to do synthetic division again, but with x equals 2 on this line. So now I'm going to do synthetic division again. I'm no longer looking at that part, and I'm going to bring down my 1 again. I'm going to just go and do 1 times 2 is 2, negative 1 plus 2 is 1, 1 times 2 is 2, 2 and 2 is 4. The reason I talked it out this time is because I did have some students in the class. We have some students in the class that are still not certain of how to do synthetic division. So please, please, please make sure you know how to do this part. Okay, and I got 0. Now, let's look and see what we have left for our polynomial. To rewrite this, I have x cubed, so I dropped 2 degrees, right? I was at the 5th power, then I was at a 4th power, and I'm at a 3rd power. So it's 1x cubed plus x squared, and then plus 4x plus 4 equals 0. We need to set it equals 0 to solve for it. We are solving here if you're not sure. Let's do grouping and see if this works. I can take something out of these two. I can take something out of these two. These match. So now I can keep going and I can say x squared plus 4 and x plus 1 equals 0, which means that my blue will give me x, this one will give me x equals negative 1. This one was something that we missed on the test quite a bit, so I'll show the work for it. X squared plus 4 equals 0, which means x squared equals negative 4 when I move the 4 over. And then when I take the square root, sorry about that, when I take the square root, okay, go away. Okay. When I take the square root, I take the square root of 4, which is 2, and I take the square root of the negative side of the square root, which is I, and I get a plus or minus. So I get x equals plus or minus 2i and x equals negative 1. But what are my other solutions? Because I had 5 total solutions. So I had 5 total solutions. So my other solutions were the ones that I found in the table, which was x equals negative 1 and x equals 2. So I'll put those, x equals negative 1 and x equals 2. And those are my 5 solutions. And I'll just write negative 1 cleaner. Now, I don't want to move on from this problem yet because I want to go back to something that could have helped us a little bit more. Let's go to the graph. So on your calculator, hit graph, and I want you to see something here. Because you can actually tell that there were going to be imaginary solutions without necessarily having to do the synthetic division. So right here, so the graph kind of looks like this. Okay, we pass through and then we bounce, which means that this factor is going to be something squared. And in fact, we know what that is. That's going to be x plus 1 squared. So here were 2 solutions right there. 2 solutions. Whenever we have a bounce, we have at least 2 solutions. Passing through, we usually just have 1 solution. If we know we were supposed to have 5 solutions altogether, so hang in here. If you know you're supposed to have 5 solutions altogether, and I have 2 plus 1 that I can see on a graph, then that means there's 2 more that are imaginary. And that's how we would solve that, how we would find that's how we would know whether we have 2 imaginary solutions or not on a graph, without being able to see, without actually being able to see those solutions on the graph. Okay, so I don't know if that was as clear as I wanted to be, but I'm going to go and keep going for the sake of time. Again, please pause if you're not able to keep up. Don't factor these. In fact, do not factor these. Use the calculator. For this one, we expect 3 solutions total. I might see 1 solution, 2, or 3 solutions on the graph, and we'll see what we can see in just a second. So let's go to y equals, clear it out, and start typing it in. And again, if you can, please work ahead of me here. But I have to go because my mad at me. She's gonna be, where were you, Dad? Were you making a video again? I'll be like, no. Holy moly guacamole. Now I see a couple solutions here. I see -3 and -2. So let's see here. I see x equals -3 and x equals -2. Those both had y values of 0. Y values of 0, which means that these are the solutions. But I'm supposed to have one more because I'm supposed to have 3. 1, 2, what's the third one? Well, if I look at the graph, I should expect something to repeat. So the missing one means that one of those roots, one root must repeat, or it's imaginary. So let's see. If a root repeats, then I should expect a bounce at one of those roots. So let's take a look and see what happens on the graph. Oh, looks like it bounces. All right, that was a little bit annoying. I'm going to do this thing called zoom box because I just want to zoom in on that part. What I'm going to do with zoom box, I'm going to go over. I'm going to move my cursor over and kind of make a window around this little portion here. So I have a top left here, corner of my box. I'm going to push enter, and I'm going to go down and right and down. I just want to make sure that there's really a bounce there. I think there is. When you use this function on the calculator, it will zoom in on the box that you drew. Now let's see what happens. Passes through and bounces. Perfect. Okay, that means at -2, there was a bounce. So my other root here, was x equals -2. There were 2 of those that appeared because of the bounce. That's how I do the work, guys. Go work on your homework. Thanks for watching.